Welcome to AI Frontiers. Today's episode explores the new frontier of robotics, adaptation, sensing, and autonomy. We highlight breakthrough research from September 2025 in the field of computer science robotics, or cs.RO. Discover how 32 cutting-edge papers are transforming robots from code repeaters into real-world autonomous learners. Stay tuned for a special feature on Ward et al.'s Paper of the Day, as we dive into the latest in robotic adaptation and learning. Consider this. Robots can now teach themselves how to walk on ice seconds after encountering it for the first time. No pre-programmed instructions, just real-time learning and adaptation. Imagine a machine designed for stable ground, suddenly gliding onto a frozen rink. No warning, no manual, no human intervention. This scenario is now possible thanks to recent advances in robotics research. The technology showcased today demonstrates that adaptation to unpredictable environments, such as ice, is no longer science fiction, but a present reality. Robotics is no longer just about repetition or automation. Today's robots are becoming explorers and adaptive partners, not just tools for specific tasks. Real-world adaptation is a central research objective, enabling machines to learn, improvise, and thrive in diverse environments. These advancements impact various sectors, from hospitals and farms to disaster response in homes. This episode unpacks how robots learn, adapt, and collaborate, emphasizing the growing significance of robotics for everyone's daily life. The field of robotics, designated as cs.RO, is an interdisciplinary arena often likened to a team sport. Robotics unites mechanical engineering, electrical engineering, computer science, psychology, and neuroscience, each contributing unique expertise such as actuation, control systems, cognition, and perception. This collaboration resembles players huddling in a digital locker room, sharing strategies and breakthroughs. Robots are now evolving beyond factory lines, emerging as vital partners that enhance human capabilities across various domains. A dominant theme in current robotics research is embodied intelligence and adaptation. Robots are being designed to improvise in unpredictable, messy, real-world environments. For example, the work of Ward et al. Demonstrates robots that adapt instantly to sudden changes in terrain, such as transitioning from solid ground to slippery ice without a stumble. This adaptability is enabled by internal models, or compasses, which recalibrate in real time. Much like sailors adjusting sails in shifting winds, the technical core of this progress is online adaptation, allowing robots to update their behavioral models instantly as conditions change. Multimodal perception and sensing represent another major advance. Robots can now fuse inputs from vision, radar, LiDAR, and tactile sensors, as explored by Lorenz et al. This sensor fusion allows machines to perceive their environment in rich, overlapping layers, akin to humans using all senses simultaneously. A practical example includes gesture recognition from across a room, where robots interpret complex signals and respond intelligently. By integrating multiple sensory modalities, robots achieve a form of sixth sense, enabling more robust and adaptive real-world operation. Cross-embodiment and generalization are reshaping robot intelligence. Foundation models, such as those studied by Eslami et al., now control diverse robot types, ranging from aerial drones to walking and grasping robots using shared architectures. This is analogous to a conductor leading different instruments with the same score. Robots can switch seamlessly between tasks like flying, walking, and manipulation without extensive retraining. Data-efficient learning further enhances this process, enabling broader generalization with less training data and facilitating rapid adaptation across new platforms and environments. Several key findings from this month's research illustrate tangible progress in robotics. Ward et al. Have shown that robots can instantly adapt to abrupt environmental changes, such as encountering ice. Lorenz et al. Introduced calibration-free inertial tracking, simplifying motion capture for both robots and humans. Goel et al. Developed adversarial stress tests, substantially improving robot control robustness by exposing systems to intentionally challenging scenarios. Islavi et al. Demonstrated that physics-driven, data-efficient learning methods unlock safer, more reliable robots capable of handling the unpredictability of real-world settings. The paper of the day spotlights a critical challenge in robotics, enabling robots to adapt autonomously to hazardous and unpredictable environments. Ward et al. Address this by developing a system for online dynamics adaptation, allowing robots to learn from sensor data in a matter of seconds. This approach eliminates the need for human intervention or advance warning. The method was evaluated in both simulation and real-world experiments, including tests on ice rinks and abrupt terrain shifts, demonstrating the feasibility of real-time autonomy for demanding applications. Delving into the technical details, Ward et al.'s method leverages neural function encoders to continuously summarize a robot's dynamic state. Recursive least squares, a mathematical technique, enables fast, constant-time updates as new sensor data is received. This process allows the robot to learn from each moment without requiring lengthy retraining or optimization sessions. The approach was rigorously tested across the Van der Pol oscillator, Unity simulation environments, and real-world trials with the ClearPath Jackal robot, showcasing reliable adaptation under varied and challenging conditions. The impact of real-time adaptation is profound. Robots equipped with these methods maintain stability and significantly reduce collisions, which is critical for mission success in unpredictable environments. The research philosophy has shifted from programming robots for every conceivable scenario to enabling them to learn continuously from experience. By embracing the inherent messiness of the real world, researchers have unlocked new capabilities for robots, making them suitable for disaster response, exploration, and deployment in settings where unpredictability is the norm. Looking forward, the field of robotics is poised to move beyond specialized machines toward true generalists, robots capable of tackling a wide variety of tasks, hardware platforms, and environments with minimal retraining. Standardized adversarial testing will enhance real-world robustness, while the fusion of learning-based and physics-driven approaches will empower smarter adaptation. This progress is comparable to pioneers inventing new forms of travel, equipped with better maps, compasses, and resilient footwear as they chart unexplored territory. The vision is for robots to become adaptive explorers, prepared for whatever challenges the world presents. In summary, robotics is advancing rapidly through breakthroughs in adaptation, multimodal sensing, and human-robot collaboration. The work of Ward et al. And other leading researchers is pushing robot autonomy well beyond the confines of the laboratory. The journey is ongoing, and everyone is encouraged to join by reading research, sharing insights, building projects, and imagining new possibilities. The collective curiosity and engagement of the community are key drivers of future breakthroughs in robotics. This content has been synthesized using advanced AI tools, including GPT 4.1 for summarization and TTS by OpenAI. Supporting visuals were generated with Google Image Tools. All synthesized content has undergone expert human review to ensure technical accuracy, though some oversights may still exist. Full references for all discussed research papers are provided for further exploration. AI Frontiers aims to deliver rigorously reviewed, accessible insights at the intersection of artificial intelligence and robotics. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from the arXiv preprint server. From neural networks to quantum computing, complex research is simplified so listeners can stay ahead. Whether a developer, researcher, or tech enthusiast, AI Frontiers provides daily updates to keep you informed. Thank you for listening. If you enjoyed this episode, subscribe for daily insights. More cutting-edge AI research awaits tomorrow. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.